Hey guys, I'm Volen and welcome to day 9 already of Advent of Code. The last couple of days have been easy. I am kind of afraid that today will be another very difficult one. But yeah, let's see. So 4, 3, 2, 1. And let's start. So day 9, Disk Fragmented. Another push of the button leaves you in the familiar hallways of some friendly amphipods? Good thing you each somehow got your own personal mini submarine. The historians jet away in search of the chief, mostly by driving directly into walls. While the historians quickly figure out how to pilot these things, you notice an amphipod in the corner struggling with his computer. He's trying to make more contiguous free space by compacting all of the files, but his program isn't working. You offer to help. He shows you the disk map, your puzzle input. He's already generated. The disk map uses a dense format to represent the layout of files and free space on the disk. The digits alternate between indicating the length of a file and the length of free space. So a disk map like 1, 2, 3, 4, 5 would represent a 1 block file, 2 blocks of free space, a 3 block file, 4 blocks of free space, and then a 5 block file. A disk map like 90909 would represent 3 9 block files in a row, with no free space in between them. Each file on disk also has an ID number, based on the order of the files as they appear before they are rearranged, starting with ID 0. So the disk map 12345 has 3 files, a 1 block file with ID 0, a 3 block file with ID 1, 5 block file with ID 2, using a character for each block where digits are the file ID and dot is free space. The disk map 12345 represents these individual blocks. So 0 dot dot 111 dot 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 and then 5 twos. The first example above represents these individual blocks. Oh wait, this is going big. Okay, so the amphipod would like to move file blocks one at a time from the end of the disk to the leftmost free space block until there are no gaps remaining between file blocks. For the disk map 12345, the process looks like this. So we basically, it's kind of an easy one then. If this is the case, that will be kind of easy. The first example requires a few more steps. So we have all this data and then we just move one by one in all the 3 blocks. The final step of this file compacting process is to update the file system checksum. To calculate the checksum, add up the results of multiplying each of these blocks and position with the file ID number it contains. The leftmost block is in position 0. If a block contains free space, skip it instead. Continuing the first example, the first few blocks positions multiplied by its file ID number are 0 times 0, 0, 1 times 0, 2 times 9, 3 times 9, 27. Okay, so we just take the ID and then we do that times and just add that up. So compact the amphipod's hard drive using the process here requested. What is the resulting file system check? Be careful copying pasting the input for this puzzle. It is a single very long line. Yes, this is indeed a very long line. 19,999 characters. Okay, well, let's save that and let's start. I don't think this is too difficult. So, I think there's like a 1 hour quest. I think because it's Monday, they make it easier, I guess. But yeah, so I guess we need to do the, let's var l IDs, ID, how do we do this? Okay, I'll need a second to figure things out, I think. Okay, so we go through all the things in the string. Then for result, I think we need to use a packed string array, because in the example we go from 0 till ID 9. But I think the ID keeps going up, so then we will have things like 11 and such. But every dot should be like a file ID. So I'm not certain if it like goes to 10. So I think the moment that we start with 10, then we have 2 numbers and that should still be in 1 block. So I think this is kind of then a misinterpretation, or do we start from 0 again after 9? Did I read the question correctly? Okay, I'm not 100% certain about this, but let's just do percent. Like, I can't really find it in the thing itself, and the problem of today, in the whole story. Math, I'm not going to do today. So I just divide all the inputs into two separate, well, strings, and then I just add them to results like that. I am not certain how to do the file ID still. So yeah, I for now I just, oh wait, I even pass the incorrect thing. This will be just kinda. Or let's just do this in case. Voila. Append should be a string, but it is an integer. Okay. Let's see if this works. So this does work, but we should have 9 in a row, and we only have. This does not work. So first we check if there is a free space, but we should also know if there is still like another number before that. Well, after that. So I think we should create a function. So pos, and we need an array, which is a packed string array. Okay, so my plan is I send in the results, but I slice it on the index where I am right now, and then I send an ID. So if it's -1, we are done. So if L index is equals to -1, we're basically done, and we break. Now here we need to calculate the results then. Then we need to remove the number from the back so that does not appear anymore. Well, not remove, but we need to make it invalid. So L results I plus L index needs to become a dot. Out of bounds. Where is it out of bounds? Okay, so we're already not doing a good job. Let's check now. Okay, so we get something, but these are the fixed results, so I should probably take the correct data. Okay, let's see. Do I get it correct or not? Okay, this looks correct, but how will it work with like a big string? Because I still don't know if I need to take the numbers separate or not. Oh wait, we also still need to calculate the results. So how do we do that? L value plus equals a results. We take the index, and we do that times the index. We return L value. But we also need to check if a results and the I is just a dot, because there's still the dots inside of it. Break. Okay, let's see. So the correct result should be, I should probably return the results, calculate results, and let's pass in L results. Let's run this, and in the meantime, let's quickly check. We have 1298, so that works. Let's take the test, let's remove test data, and let's take the normal data. Okay, we got a reply, and I should probably not have checked the result, because now it printed like an entire thing. Okay, so we have this number. Will the file numbers go up by more than like 9, or will they loop back at 0? Let's see. That's not the right answer. If you're stuck, okay, so well, let's just remove this. Let's make that a string. And let's see if this works. Oh, let's first test on the test data. So with the test data, we get 1928. That's still the correct result normally. 1928. Okay, so let's see. Was my idea of doing the whole going to 10? Like, it doesn't make sense that the file IDs would loop back to 0. But yeah, I was kind of stuck with that. Probably just bad thinking, planning. Let's see. This will take some time again. Okay, and let's see if this string is the result. It did not crash, so I think this should be correct. Let's hope, yeah. Okay, so we did not have to do the whole 10. So that's the right answer. You're 1 gold star closer to finding the chief historian. So continue to part 2. Upon completion, 2 things immediately become clear. First, the disk definitely has a lot more contiguous free space, just like the M5 pod hoped. Second, the computer is running much more slowly. maybe introducing all of that file system fragmentation was a bad idea. The eager amphipod already has a new plan. Rather than move individual blocks, he'd like to try compacting the files on his disk by moving whole files instead. This time attempt to move whole files to the leftmost span of free space blocks that could fit the file. Attempting to move each file exactly once in order of decreasing file ID number, starting with the file with the highest file ID number. Is there no span of free space to the left of a file that is large enough to fit the file? The file does not move. Okay, so that makes things a little bit more complicated. And the first example from above now proceeds differently. Decreasing file ID number. So we still take the beginning and we just see if it fits or not. If it does not fit, then we just don't move it. But I can see that 555 would fit, could fit inside of here. Same for 666. Why does that not, and like also 888, why does that not move? Okay, a little bit of thinking time again. Okay, so I added a new check result and I created a function to get the initial results, so not the actual results, initial results, and something is wrong here already. So this makes the function a little bit shorter, but now we need to I think we need to get an exclude array. So var l excludes, which is a packed string array, and let's... Okay, so I've gotten a little bit further. Right now, it appears to be going somewhat well, except for we're not skipping the dots at all. So I think we should do L, how about we do L pref ID is the same as -1. Maybe that will work? Okay, but we do change the 99. Okay, okay, I really need to rethink this entire thing. I thought I had it. Okay, so a lot has changed, but I think I almost got the correct solution. So what am I doing first? First of all, I am making the data and compile. So compile L data. That's what this does. It basically creates an ID, so the number of the file, and the value is the size. After that, we start a loop to make L results correct. So we have our index, we have our size, and we basically just go over everything, and when we find the dots, if it's the first one, we set the index to that specific spot, and else we just append, well, not else, and we also adjust L size +1. Then we check, it's not a dot anymore, and L index is also not -1 anymore. Then there is a free space. And then we check which selected one from the data, from the ones in data, fits. And we go from high to low. So we do the size -x. I do find to make certain. I do find from -I. If that is -1, then we we should not continue anymore. Then we have our data itself. It selects the data. Then it does this to first remove previous occurrences out of L results. Then we change add the correct numbers in the correct positions. And then we also delete the key out of L data plus eventual other ones if we skipped some. So yeah, let's check. Normal, I think this should I have nothing changed. I was almost I did some test results and this was the last thing that I added. Wait, L results.find. L results.find returns its index or -1 if not found. So if it's not found, it should that should be the correct one. So let's quickly check. So this is not correct. Why is this not correct? Okay, so new attempt. I compile the data, I'll compile all the free blocks, and then I'll just go into a while loop until all the free blocks are gone, or until ldata.size is basically 1, because the first character normally is, yeah, it's a valid file ID. So it does something strange. So it moves everything and it just disappears into nothing. So something is still going wrong. Okay, I basically deleted everything again and I'm starting from scratch again because I decided to read the question one more time and I kind of figured that I should just read every single number from the back, count how many spots there are, try to find the next empty space, and if you go past the index that we're currently at, we just skip it. It's as simple as this. This was just a matter of me not reading the question properly again. At this rate, I'm kind of wondering if I should keep doing Advent of Codes or if I should just invest this time in Gozen. At this rate, I feel like I will spend way too much time doing these challenges to the point that it's not really worth it anymore, and also the last couple of episodes don't really have many views anyway, so the video started out big with like lots of views, like over 400 and 600 and such, but the last 3 or so episodes it's been kind of flatlining, so yeah, I'm wondering if I should continue. I will probably still do them in my own time anyway, and maybe I will record them afterwards, but like talk about how I came to my solutions, but at this rate to film this and try to make it entertaining, short, and do the editing and the filming on the same day and solving the problem on the same day, it is time consuming. My entire afternoon from 2 o'clock all the way until the evening is basically being taken up by this. So yeah, oh well, let's implement this and let's see how it goes. And I finally got it working. I spent way too much time on this again. It's like 3.5 hours now, but it finally works. So the way that I did it is with a combination of my previous results. So I saved the ID, the size, the free size index. So first I find I go to the back of the array, find the first number, count how long that is, and then I check all the free spaces from the beginning. And if it does not fit, then we just go to the next number, check again the entire array until the point where those numbers start. And like that. It works. I have the correct number now, 2858. The positive thing about these type of puzzles, you can easily see where you're going wrong. The downside is I feel like I'm not good at these kind of puzzles and it's taking me way too much time. So from now on, I won't quit Advent of Code, but I think I will limit myself to 2 hours in a day. If I cannot solve it in 2 hours, then shanai. So yeah, I cannot keep spending so many hours because I still work on Gozen as well. This morning I spent a good 6 hours on Gozen. I need to get work done on that as well. And this of course takes some time, so yeah. Okay, I did make the mistake of leaving the print check on. I should probably not have done that. And I hope I can copy this. Yeah, okay. Sometimes Godot just does not let me do it. So, submit. My first 1-star day. Thanks for watching. Thanks to my Ko-fi supporters. At least my Ko-fi supporters don't make me feel this bad. And yeah, see you in the next one. If there will be a next one, I don't know yet. Bye bye. Okay, I don't know how, but I changed one value. I added +1 here and suddenly it's correct. So, okay. Apparently I have 2 stars. I'm a little bit happier now, but still over 3.5 hours gone. Yeah. Anyway, same as before. Bye bye. See you tomorrow.